Good morning, everybody. And this is a very interesting question. In fact, it is a very hypothetical question. All of us know that the earth is moving around the sun. So, this is the sun, and that's the earth. And the earth moves around the sun in an orbit, in an elliptical orbit. And if all of a sudden the earth stops orbiting around the sun, what would happen? What would happen is the earth will be pulled towards the sun. If the earth is not moving into the orbit, if the earth is not moving the orbit, it will pull towards the earth, pull towards the sun. Now you have to find out when the earth crashes into the sun, what is the speed of the earth, and how would you calculate this one? So here is the question. If the earth suddenly stopped orbiting around the sun, it will be pulled towards the sun, and you have to find out the speed of the earth with which it crashes into the sun. So first let's write down all the given values. The mass of the earth is given, that's the 5.96 times 10 to the 24 kilogram. The mass of the sun is given. The radius of the earth is given, the radius of the sun is given, and the universal gravitational constant, the capital G, is also given. And also the distance between the earth and the sun, that is also known, that we call the one astronomical unit, is also given, which is 1.5 times 10 to the 11 meter. So we have all the given information, and from this information we have to find out if the earth stops orbiting around the sun, it will be pulled towards the earth, and what speed it will crash into the sun. So what's the idea, what's the strategy, how are we going to find out? The only thing we have to understand here is the total energy of the system. Earth is very tiny mass in compared to the sun, very tiny. So what's the point is the total energy of the earth at each point will be exactly the same. Here, if the earth stops orbiting around the sun, it will only have the potential energy, the gravitational potential energy. And then as the earth keeps crashing into the sun, it will have both the potential energy plus kinetic energy, but the total energy will be exactly the same. What does this mean? That means the potential energy at this point, or the total energy at this point, will be exactly as the total energy at this point, or the total energy when it crashes into the sun. This is just like, let's say you throw an object. This is the earth surface, that's the earth surface here. You throw an object upward direction, the total energy at the maximum height is exactly equal to the total energy with which you throw the object. The total mechanical energy at all points will remain exactly the same. That's the conservation of energy or mechanical energy. So all we have to find out is the total energy at this point and the total energy when it crashes into the sun. Okay, so that's what I have written down here. So the total energy will be the kinetic energy plus potential energy at this point when it stops orbiting around the sun, and the total energy when it crashes into the sun. So what are the kinetic energy? If the earth suddenly stops orbiting, its velocity would be zero. So that means the kinetic energy is zero. That's the equation for the kinetic energy. Remember, this is the kinetic energy equation. And the potential energy at this point, you know the potential energy formula. The potential energy is given by G m over R. And this G is the universal gravitational constant. M is the mass of the earth or the mass of the sun, and small m is the mass of the earth, and R is the distance between the earth and the sun. That's what I had exactly written down here. That's exactly G. This is the equation for the potential energy. G is the universal gravitational constant, m is the mass of the earth, ms is the mass of the sun, and r1 is the distance between the earth and the sun, which you call here r1. Okay, that's the r1. And now when the earth crashes into the sun, we have to write down exactly the same equation: kinetic energy plus potential energy. What is the kinetic energy? We know the kinetic energy. The formula for kinetic energy is 1/2 mv squared. And as the earth is moving, we have to write down the mass of the earth and the speed of the earth square. And the potential energy, remember one more time, the potential energy is G, and mass of the earth, mass of the sun divided by the r, the distance between them. That's the r value. So here at this point, G, m is the mass of the earth, mass of the sun, and the distance here that we call as an r2. R2 here. So that's what the R2 is. Okay, the R2 will be the R2 in fact will be the radius of the sun plus the radius of the earth. If you zoom in here, so this distance plus this distance here, when it just touches the sun, okay, so the R2 here is the RS plus RE. When it just touches, it will be equal to the radius of the sun plus the radius of the earth. That will be the distance between the earth and the sun when it just touches the earth sun surface. So now here this one is 0 because it is not moving at all, or it just stopped orbiting around the sun. And in each term we have the mass of the earth, so I can simply take the mass of the earth out from the equation. That simplifies the equation, and all we have to solve for is this speed v2. The v2 is the speed when the earth touches the sun surface, and if I solve it, I'll get this equation here just by solving this equation. And now all I have to do is plug in all the values. We know the universal gravitational constant, we know the mass of the earth, we know the R2. What is the R2? Again, R2 here will be the radius of the earth plus the radius of the sun in this equation. So we know all the numbers here. So all we have to do is plug into this equation. And if we plug in and solve, this is the number we'll get: 6.15 times 10 to the 5 meter per second. That means if the earth stops orbiting around the sun, it will be pulled towards the sun, and when it crashes into the sun, it crashes with this speed. Okay, so all we have to solve is by using the conservation of energy, and all you need to know what is the kinetic energy and potential energy at 2 points, at this point and at this point here. If you do that, life is so easy, or you can solve this problem rather easily. Okay, if you have any questions, any concern, please write to me and I will get back to you. So this is it from this video. If you have any questions, again write to me, and do not forget to like, share and subscribe the channel. Thank you very much.